Oh, hi, good evening. Tonight I'm going to continue from last session about the using the bridge to check the SWR. So basically the formula is here. This is the bridge, and so this is what as we said. So the formula is basically need to put the spatial analyzer here and do one reference check when this A port is open. So the signal goes to from B to A and just bounce to C. And this is a reference point. Then put antenna there, then do another check at the port C. And the difference here divided by 20, this is in dB. And you can get this value. And this value you plug this in, you get SWR. Okay. I did not I did not mention one thing. In when we deducted this formula, we have one assumption. I mean, first, the loss on this AB line is irrelevant. From A to C, the loss is irrelevant. Is okay. Even we're talking about the loss, a different frequency has different loss. That's still okay. The only thing not okay is the loss depending on the amplitude. We always assume that the loss, this loss, A to C loss, is irrelevant to the amplitude. But if it's relevant to the amplitude, then it's the formula is wrong. Another thing we an assumption that the loss not loss the signal from B and to A, and there's we assume that all the signal from B to A is go to the antenna. And this assumption means that if we have the antenna here, and the signal all goes to the antenna, then it's bounce back. The bounce back signal split. There's no signal from B to A and jump to the C. So all what we deducted here is correct under two assumptions. First, the signal from B to A, and if there's a antenna or there's a load, all goes to the antenna. This this one assumption. Second assumption that the amplitude is not dependent on the frequency. Let's check a real one to see if that's the case. Okay, for this one we check this A to B first. A to B is straight. This is A. Oh, this is A port. This is B port. Let me set this right. Okay, this set up. So from this B port, it goes to the A port, and this is the C port. C port feed to a dummy load, which means that it does not reflect the signal. Let's see the signal. Okay, this is the entire band from 0 all the way to 3 gig. We can see the loss is around. We're talking about this portion, which is UHF, VHF. I would say around 7 dB, 6 dB. So let's say 7 dB across the board. Uh, 7 dB. And let's look at the loss from A to C. Before I do that, I switch the port. Okay, so now it's instead of from B to A, now it's A to B. This is A port to the B, and you can see the spectrum analyzer shows same curve. It means that this is A to B, B to A. There is bi-directional, no difference. Okay. Okay, now signal is feeding from port A to C. So A to C. Let's see. Well, it's almost similar to the previous one. 7.7 dB loss in this region. So let's write down 7.7 dB loss. There are two loss here. Another B to C. B to C, one is A is have a dummy load, and it's taking all the signal from. If we send a signal from B, and if A put a dummy load, A will take all the signal out, and we check what's the isolation here. Another is like A is open. Let's check the A first. A is open. See what's the signal go to the C. Okay, this setup A is open. A port is open just from B directly to C. Let's see. In the region we're interested, it's about 15 dB lower. So the isolation between these two is 15 dB. A is open. Now let's see A is closed. Closed means that there's a dummy load here. So ideally, it will suck all the signal out, leave very little to C. Okay, this is the setup. This is B feed to the C, but B feed the signal to A, but this dummy load takes all the signal out, and leave a little bit bounce back to here. And let's see what's the result. This shows here is 50 dB lower, but here is bumpy, so it's not really smooth. This is not all crossband, so this is not good, not that flat. I would say in the area we interested maybe 50 dB at least. So based on this number, what's our conclusion? First, this box is not good for monitoring, because if I feed the signal from A and the signal is cutting 7 dB lower, 7 dB is almost 6, 8 times lower, so I lose quite a lot. And this for monitoring port, the signal is too strong. Normally I send a huge number of the signal here and go to the antenna at B, but this C can only take a little bit power, but now it's split evenly, so this C will damage this monitoring device. Also, antenna does not get enough power. And the isolation here, when A is open, 15 dB lower, so the signal goes to here, loss 7, another loss 8, so this is addition of these two numbers. It's okay, but this number 15 dB lower, when the signal sucked out 15 dB lower, it's also okay. We want this number as low as possible, but 50 dB is a pretty good number already. So overall, this bridge is just good for checking the SWR. Not much other usage. Thanks.